Let's start graphing. You've seen some of these graphs before. We are going to go a little bit slowly at first, even though it seems really basic. We're going to graph y equals x. This is a line. This is a review. So let's plot some x values and some y values. And the y values are going to be based on the fact that it's equal to x. So if we just made up some x values, -2, -1, 0, 1, 2, and I wanted to know what y value I would get, then, well, let's look at this. So y would equal to whatever the x value is. So it'd be -2, and then -1. Well, it's the same thing, and it's the same thing, and the same thing, and the same thing, because y and x are equal. So what I'm going to do now is just plot those points. I'm going to plot them in red, and that gives me -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. And clearly we have a line. Now, I knew that from the beginning. You knew that from the beginning. But there's our line, 3, 3, 4, 4, 5, 5, 6, 6. There we go. Input equals output. Diagonal line. Now, if you want to get all technical, and we should, this is going to be the same structure as y equals mx plus b. So you could say my slope is 1. Okay, so rise 1, run 1. So I'm going to go up 1, I'm going to go over 1. And so that gives me a slope of 1. And then my y-intercept is 0 across the y-axis at 0. So again, what we're staring at here is, well, a line. It's a perfectly straight line. So this problem and this problem and this problem are linear, and we're just going to go with that. So linear. If it's of this form, it is linear. And linear means that you're going to have an exponent of 1, and it's going to look like y equals mx plus b, maybe restructured in some way. Okay, let's do the next problem, and we're going to do the same thing with the table of values. So we're going to have x and we're going to have y, but in this case y is not equal to x. Y is equal to 2x. So double your x. So -2, -1, 0, 1, 2. Where am I getting those numbers? I'm making them up. Just trying to find some x values. I like to pick some around the origin. That works. So if I do 2 times -2, I'd get -4. 2 times -1 would be -2. 2 times 0, 2 times 1, 2 times 2. We're going to plot these points. And when I do, we'll see, we'll have -2, -4. There we go. -1, -2. 0, 0. 1, 2. 2, 4. 3, 6. Just double it. Like whatever you say first, double it to say the second one. 4, 8. 5, 10. 6, 12. A million. 2 million. There we go. And there's our line. Again, this one is also linear because it's, well, a line. And if you want to get all technical with your slope-intercept form, your slope is 2. 2 over 1 if you want to really get technical with slope. Rise 2, run 1. Same thing here, rise 1, run 1. And my lights just went out. We'll just keep going. Plus 0. If I sit still long enough, the lights go out. It's kind of awkward when you're recording videos. We're going to slide up to this one, and I'm going to strategically pick some x values that will work in our favor. So we're going to have x and then y, and y is equal to -1/2 x minus 1. This is going to get a little trickier. And again, strategically picking x values. We're going to go -4, -2, 0, 2, and 4. I'm picking even ones because of this even denominator. Trust me, it works. It's going to turn out nice and neat, and we'll avoid some decimals, even though decimals are wonderful things. Okay, let's plug in a -4. We'll show the work on this one. Plug in a -4, so -1/2 times -4 minus 1. Now, if you're like, slope-intercept form, let's just graph it. I hear you. I want to just show you a process, though. -1/2 times -4 would be positive, and then half of 4 is 2, so 2 minus 1, which is 1. Work's getting a little cluttered here, but that means my first coordinate is at -4, comma, 1. Hope you can see that okay with the lights out. Actually, I think it's showing up quite nicely. I'm having a hard time seeing the paper, but, you know, whatever. Just start writing anywhere. -1/2 times -2 minus 1. Okay, that's 1/2 times 2. That'd be 1, and they're positive, so it's 1 minus 1, which is 0, which means I'm going to plot the point, -2, 0. Now, okay, here's the deal. Knowing this is a line, I could just go ahead and connect any 2 points can make a straight line. So we have 2 points that make a straight line. And I could, if I would have thought ahead and grabbed a ruler, but that would turn the lights on when I get up and the motion detector goes off. Can just extend this, and that's going to continue this process. Because, for example, the very next one, if I plugged in a 0, negative 1/2 times 0 minus 1 is going to give me 0 minus 1, which is negative 1. And there it is right there, 0, negative 1. And I have a line. So here's your whole slope-intercept deal. My goodness, that's a messed up line on that end. Not too straight on that end either. All right. So didn't even finish the chart. Don't even have to. I mean, I could if I wanted to, like 2, negative 2, 4, negative 3. There we go. But here's your slope-intercept, right? So your slope-intercept is, well, a slope of negative 1/2, a y-intercept of negative 1. And this is your starting point. I always like to start with the y-intercept. So we'll start at negative 1. So the y-intercept is negative 1. And then our slope is negative 1/2, which means we would, from our y-intercept, go down 1 and to the right 2. Negative 1, positive 2.